Hello everyone, and welcome to Catchpoint's 5th live AMA, or Ask Me Anything, on the Internet of Things, security, innovation, and the future. My name is Robert Castley, and I'm going to be your moderator today. I am a senior performance engineer at Catchpoint for EMEA, and I've been with Catchpoint for over 3 years now. Little fun fact about me is that I've actually served 3 British Prime Ministers within my time. Not in the IT world, but back in my catering days. So we have a few housekeeping notes before we kick off on the AMA. All attendee lines will be muted, and the presentation is being recorded and will be sent out over the next few business days. So please feel free to use the Q&A feature in the Zoom meeting, and time permitting, we will try and get to answer a few of those questions. So let's start off by introducing today's AMA panelists. First, we have Vint Cerf. Vint is the Chief Internet Evangelist at Google, and Vint is recognized as one of the fathers of the Internet. He shares this title with TCP/IP co-inventor Bob Kahn and holds several honorary degrees. And those awards include the National Medal of Technology, the Turing Award, the Presidential Medal of Freedom, the Macaroni Prize, and the membership in the National Academy of Engineering. Deep breath, that was a lot. So, a fun fact about Vint. In 1994, he got a 1-page spread in People magazine, but in 1998, his wife Sigrid had got 6 pages. I've always said it's about quality, not quantity. So great to see you here today, Vint. Thank you.
Oh, thanks so much for having me on the panel. I'm looking forward to this discussion.
Excellent. Next, I'm actually joined by a fellow British citizen, which means that I'm now going to be 2 British accents on this AMA this time. So we have Andy Stanford-Clark, IBM Distinguished Engineer for the Internet of Things. Andy is also one of the IBM's master inventors, which means, among other things, he invents lots of cool things and gets lots of patents. And his current role is Distinguished Engineer for IBM Watson Internet of Things platform, which means he works with clients to help them use IoT and understand where IoT comes into their business. And a fun fact about Andy, he lives on a small island called the Isle of Wight off the south coast of England and keeps 4 llamas as pets. I've just got a dog, Andy, so I don't know how you look after all those llamas, but great to have you here. Thank you.
Thanks, Robert. It's great to be here.
And last, but certainly not least, we have Dr. Sarah Cooper, General Manager of IoT Solutions at Amazon Web Services, as well as Vice Chairwoman of the Internet of Things community, whose flagship conference, IoT Slam Live, kicks off in North Carolina tomorrow. So we're very lucky to be able for her to spare time with us today. Sarah was named an IS50 Most Empowering Woman in Business, recognized top 100 wireless technology expert by Wireless World, a National Academy of Engineer Frontiers of Engineering awardee, multidisciplinary entrepreneur, inventor of IoT medical battery that runs on body temperature, and a PhD in physics from University of Sydney. That was another load of big words I had to deal with there. So a fun fact about Sarah is that she started her first business at age 9 and then went on to charge interest on monies borrowed by those that provided a roof over her head. Great to have you here today, Sarah. Thank you.
Thanks, Robert. There's nothing better than interest from parents on pony money.
Just you wait until your siblings do the same to you. So great, we have some fantastic questions submitted by the users that have submitted them over the last few weeks. So we'll dive right in. So Vint, I hope you're ready. So the first question is for you. What are the security risks of IoT that you are most concerned about?
Well, if I were a poet, I'd start out to how many security risks are there? Let me count the ways. But since I'm not a poet, let me just observe that probably the most significant risk is the lack of resistance in most of these devices to being accessed inappropriately or in an unauthorized way. So we need strong authentication mechanisms to allow a device essentially to defend itself either from inappropriate control or from exposing information to a party that shouldn't have access to it. And just to show how tricky this can be, even something as simple as temperature information coming from every room in the house, accumulated over a period of 5 or 6 months, could give an observer some sense for how many people are in the house, what their diurnal patterns are, maybe whether they're home or not. And if you're planning to break into the house, that could be useful information. So access control, from my point of view, both to control and access to data, is the biggest security risk that I've been able to identify. But I'm very, very curious to hear what the other panelists have to say about that issue. So maybe we could go on to see what their thoughts are as well. Sarah, especially.
Oh boy, security is certainly one of the biggest challenges to adoption. It also means everything to everybody. If you talk to device people, they want to talk about roots of trust all the way from silicon all the way up. If you talk to application folks, they want to understand how behavior of devices in an ecosystem are changing. I think one of the things that we need to be very clear about with security concerns is what are we actually securing? Are we securing the value that IoT is providing, or are we really concerned about securing the action that those devices can take? And there are plenty of IoT devices which are really sensing paradigms and not necessarily actuators. I think we need to kind of separate out those different forms of security and think differently about how we build that into our infrastructure, making sure rogue devices aren't participating in decision analytics, for instance.
If I could add one thought to your comment about sensors, even if the device isn't actually taking control of anything, the webcams that were taken over and used to launch denial of service attacks against the Dyn Corporation are a good example of how a sensor can become quite abusive if you can aim a megabit stream. 500,000 of those devices were used to target a 550 gigabit per second attack against Dyn Corporation, which essentially knocked its servers over. So even there, a sensor can be potentially damaging, even if you can't reprogram it to do something else.
Oh, I agree. I guess I meant more just that the technologies underpinning the security are different for those that are actuating physical processes. You're looking much more, for me, at the hardware at that point, and it's more important to consider what's happening on that specific device versus the overall behavior of the system. For me, on a sensor network basis, the overall behavior of the system is a better indicator of whether something has been compromised rather than any particular hardware fix. So it's sort of bottoms up versus tops down approaches to security, and the segmentation of how that gets done in an ecosystem. It was.
Yeah. And if I could just dive in there, just kind of the other end of the chain. If you're designing IoT devices, then they've got to be designed from the ground up with security in mind. So it's not an afterthought or a version 2. I've seen security added to a version 2 line item list in some to be unmentioned product. So it really has got to be secure by design, and then you can start to integrate all these technologies you've been talking about, and actually have a fighting chance of building a secure device. But that doesn't make it any easier. It's still a really hard problem.
I know Andy wants to get on to other questions, but I can't help but to make the observation that there will be bugs in the software no matter what we do. And so another thing we have to account for is how a device can load new software to fix bugs. But how does that device know that the software came from the right place and has integrity? And so once again, another area of security is the ability to update the device safely.
Absolutely, yeah.
Agreed.
So that's quite interesting, because that sort of like brings us on to, you mentioned, Vint, about the Dyn attack last year, and obviously these webcams that people are using for home security, they come with a default username and password. People don't change them. So what can be done in the world of IoT to try and overcome the human negligence of securing their own home?
Well, it's Vint again. One observation I would make is that some of these devices, if they're in a residential setting, might actually not directly connect to the internet, but through perhaps a router or gateway or some sort of device that you could add, to which you could add more filtering and control, maybe a whitelist of IP addresses that that device is allowed to interact with, for example. That's part of it. I think also we have to put the developers of these devices on notice that they really should meet certain criteria with regard to access control, and users should be warned about that. Maybe we're looking for cyber underwriters laboratory seals of approval or something that investigate the device's ability to provide that kind of functionality.
One of the things we're looking at, sorry, go on.
That's all right. I was just going to say, adding to that sense that it is in part developers who need to work on this. I think there's an expediency challenge in that, you know, we don't make things easy, and it's not just about easy, it's about what's most convenient. If it's most convenient to name your child's bedroom light bulb, you know, Jane's bedroom light bulb, and somebody sniffing traffic to know when Jane's in her bedroom because the light's on, that's probably not, you know, that's probably not a straightforward thing. That also extends, by the way, into the industrial space. You know, there's a UK smart meter incident where, you know, just before a bunch of smart meters went out, somebody realized it was in the design docs to use the same cert for all 85 million of them, just because that was an easier to manage process. That is expedient, it is not secure, and making sure that those things don't pass muster is another challenge. Sorry, Andy. I was going to
mention that there's an effort underway in the UK at the moment with called the IoT mark, to try and get together a set of guidelines where people can self-certify and comply with these things, and then we'll be allowed to carry a sort of like a tick mark to say, you know, as far as we can tell, you know, we've tried our hardest to comply with the best practices in the industry. And obviously, you shouldn't necessarily take that as a position of being able to trust it, but any that you don't have that mark, you certainly shouldn't trust.
So then we get into this question about self-certification, and you know, do we trust the parties who post that mark? Is there a third party like Underwriters Lab or something that would evaluate what, the software, maybe even the hardware and the software? This is a very tricky area, and the fact that we can get into a lot of trouble, or our customers can get into trouble inadvertently, puts quite a bit of pressure. It should put a lot of pressure on the manufacturers of these devices.
Do you think that there's a need for, I'm going to ask my own question here, do you think there's a need for a standard testing, you know, I think of some of the most impressive testing software out there are, you know, things like Metasploit. You know, should we be figuring out how to crowdsource a security testing tool? So that things like backdoors, which, you know, might be part of a legitimate dev process, are found out before they go to production. And if not, you know, before they go to production, at least there is a standard set of things that you could run, you know, your decision set across to see whether, you know, you end up with a open port or a backdoor.
Well, whether it's crowdsourced or not, I think a set of criteria that these devices should meet would be very helpful, and showing that to the manufacturers, and then something to the users to say these criteria have been met. We're far from having that agreed, and it clearly has to be global in scope, because these devices are going to come from everywhere.
Okay, so Andy, the next question is for you to kick off. So what progress has been made towards universal interoperability, and who is leading the effort? And also, does there need to be a common or standardized communication between devices? Because as we know, there are many different protocols being used in IoT today. And I guess it's like VHS versus Betamax, you know, who's going to come out on top?
Yeah, that's a really good question. And you know, I've been working in IoT for nearly 20 years now, and started off where basically you say Internet of Things standards like toothbrushes. Everyone knows you need one, but no one wants to use anybody else's. So everyone went off and invented their own one, which was a good thing and a bad thing, because it meant good thing is you've got lots to choose from. Bad news is you've got lots to choose from. And I think it depends where you are in the stack of how you can address the interoperability. So obviously, it's a sort of, if you plug your Ethernet in, then you know it's going to talk Ethernet, and then at a level above that, thanks to Vint et al., we know it's going to talk TCP/IP, so we can ensure an end-to-end session-level connection. And then we move up the stack another level and start talking about HTTP and MQTT and our favorite messaging protocols for the Internet of Things. And fortunately, there seems to be some convergence there. So things like the standardization of MQTT and XMPP and CoAP and name your favorite poison, then at least you've got some to choose from rather than people insisting on inventing their own wire protocols, which really today you shouldn't be doing. Then above that, we start to look at the semantic interoperability of devices. And I've been involved in the UK in an effort called HyperCat, which is looking at storing metadata about Internet of Things devices in a very easy to consume machine readable way, so that at least particularly in smart cities where you've got lots of different organizations coming together to make a sort of whole is greater than the sum of the parts smart city out of a whole bunch of components, you've at least got a fighting chance of finding what sensors people have got, what capabilities they've got, what units they broadcast in, what topic they're on, what their HTTP endpoint is, etc. Even if you don't then agree on what's being sent and other things, at least can find out about the phone directory part of it. So there are efforts underway. I don't think it's down to one particular organization to do it. There is a lot of efforts by particular groups of industries, like sort of Rosetta Net, people like that, to come together to create catalogs of schema for messages so they can interoperate at a messaging level. But I think it's a combination of best practices from the community, from the industry, standardization. So I think it's very important to actually use a standards-based approach rather than just one that you just happen to find in some document somewhere. So at least it's had the due diligence and attention of a standards organization. And build your stack from the bottom to the top using the appropriate standards as you see fit, because there certainly isn't one size fits all for this.
So I wonder if I could jump in. First of all, we do see many different explorations of protocol stacks in the devices that are already available on the market, and they do not confer interoperability. A lot of the makers of these devices are settling on IPv6 as sort of a low-level agreement because there is a large address space there. As you get further up the stack, you get quite a bit of variation still. There is one interesting institution called schema.org, which is a place where a lot of the semantic standards can be represented. And I think Amazon, for example, has this notion of skills, which are ways of referring to functionality of the devices. And at Google, we call it actions on Google. And I'm not sure, IBM probably has a language for this as well. It may be that all of those could be represented in the schema.org structure, and that would allow us to achieve some interworking at the command and function level. But we still need to come to some agreement about the other stack elements, which are generally invisible to the users. So I don't think the users will care very much about the specifics, but they certainly will care about being able to create an ensemble of devices from multiple brands that will interwork with each other in an ecosystem, to borrow Sarah's word. So I hope that there'll be pressure on all of us to achieve that commonality. Right now, a lot of people are making devices hoping that their particular stack will be the international standard. It's an unlikely outcome.
Very unlikely outcome, yes.
I see a tension between interoperability and kind of where we are in the maturity of IoT at the moment. And this kind of follows from what happened with a lot of network functional virtualization too, which is, if you are a device manufacturer today, how do you make sure that your device doesn't become just a complete commodity? If you're a flow meter is a flow meter. What are you adding? And so what many folks have been adding is a lock-in system on proprietary protocols, and B, some kind of an analytics platform off of just what they own in the ecosystem, which if you're a flow meter company is really just, flow within the pipe, a very important, but generally a small bit of any larger process. And so, as the refinery or the chemical plant goes to buy an IoT platform, they end up kind of ripping off this analytics piece. And we're seeing this in a lot of manufacturing customers where they are just trying to remove all embedded software and write their own across all the hardware vendors they've bought in order to deliver their own interoperability. And I think, to me, the inflection point becomes when, as an ecosystem, we have the business contracts, when we have the data exchange and the digital rights management around insight and the value that's derived at the interfaces of IoT devices, that we will really start to see interoperability, because then the dollars that you can charge for something are no longer directly related to locking in, you know, a certain customer into your platform. And at that point, you know, those who deliver more value will actually be able to generate more income. But until that point, I think interoperability for a lot of vendors is a head nod. They know they're gonna have to do it. They probably know that if they don't figure out how to do it right, they won't be around much, much past the next 10 years. But there's still some significant technology barriers as well as business barriers to making that happen.
Wow. So Vint, the next one is for you, sir. And this, I think, must have been written by somebody in marketing. So bear with me while I read this one out, okay? Is the IoT likely to contribute to the development of a global, ambient, hyper-connected, super-intelligent system where technology and humans, communities, and societies interconnect and integrate?
God, I hope not. I mean, that's the, you know, what a mongrel DNA collection this would be. Now, I have to give credit to my colleague at Google, Ray Kurzweil, whose book, The Singularity is Near, draws this question to our attention. Ray sees this proliferation of computing capability, Moore's law, and the sort of exponential growth of computing capacity, number of transistors per square centimeter, as evidence that we may get to the point where there will be human-level intellectual capability, perhaps not necessarily arising out of a large number of devices, but rather out of highly concentrated and high-density kinds of computing systems. I hope that doesn't happen. I think my preference would be for all of these devices to simply become tools that we use in order to make our lives easier, to gather data that helps us and others properly function in the world we're in. To give you a good example, when you think about Google Maps and you're navigating, one of the interesting things is if there's enough people navigating, then the feedback about how they're doing, so we have to track where they are anyway to give them directions. If we notice that there's a slowdown, we can relay that to everybody else and warn them that because the sensing system has detected that. So there's this utility in numbers. Those sorts of things I think are quite powerful, but I don't think I would imbue them with the level of singularity that the question implies.
Funny, Ray was on a board of one of the startups I did a couple of years ago. So this is a conversation, and that was a nanotechnology startup. So this is a conversation that comes into play time and time again. Each time we get kind of one of these really interesting emergent behavior type of industry that really touches almost kind of across the board in nanotech. We heard a lot about it and then it disappeared. Well, it turns out it's in everything now. We just don't have we don't have a nanotechnology industry per se. It's in the table, it's in my computer, it's probably in the coffee I just drank, nano caffeine. But I think IoT very much is going to head the same direction. And there was, prey in this whole sense that nano was going to have all of these nano machines running around. And I think for IoT, I think we're still pretty far off from truly a consciousness. It's not just about, can there be an autonomous orchestration? It's really the reasoning over these complex systems. We don't do it terribly well, but I think it'll take, there's a whole system of technologies and enabling foundation pieces that I don't believe are in place yet. But that might be the practical industry side of me speaking. Unless Andy's already invented it. Just saying.
No, I was just all of the above. What I was going to say was that IoT used to be known as pervasive computing or ubiquitous computing, and those two words very nicely describe the situation when IoT has kind of made it when you don't know it's there anymore. It's disappeared into the fabric of our lives. Everything from your light bulb to your toaster to everything, it's obviously network connected. Why wouldn't it be? And in fact, the whole sort of Internet of Things will become quite anachronistic quite soon. It'll either be the internet or things. I mean, the idea of why do you have to describe an Internet of Things? Well, of course, all the things are connected to the internet. So I think it's all around us, and as you say, it may even be in your coffee, Sarah. But it's and that's not going away. The question is whether we, as a buying public, are prepared to accept and sort of embrace the benefits that are being offered in return for what we have to give up in terms of privacy, security, giving up data, having things around us to press buttons on and replace batteries in, and all those kind of things. And for the overhead of having these things, what benefit do they bring? And that's what we, as a world, a population of the world, have to decide.
So Sarah, as technology gets smarter, do you think our abilities to think, feel, and act be affected? Now, before you answer that, just from speaking personally, I think we are indirectly affected. We don't realize we're being affected by these. I mean, how do you see it?
I don't think intelligence is a zero-sum game. I don't believe that as technology gets smarter, we get dumber. That said, I do see where there is our brains and our biological systems have developed over, I think the most recent thing I saw was 350,000 years. They found a potential Homo sapien about 350,000 years ago. If we look at the amount and the pace of change in interaction technologies, just the things that we have to interact with, cell phones are the most obvious example. I don't know that our biology has caught up to our ability to game the system. So for instance, we need to multitask in order to stay with modern productivity. Great, my phone multitasks super well. I less so. So if I'm checking email and then responding to something and then checking email and again and then trying to, at Amazon, we write a lot of working backwards documents, working backwards from what the customer needs. It's very hard to write even a 6-page document these days without checking my phone, 15,000 times to see what I've got to respond to instantly. And I think that IoT will definitely, in some respects, I think it'll exacerbate that sense of, hey, attention. And that's part of, particularly before all the devices are networked together, there isn't a lot of value to having a home security camera. You don't notice it's there. So that means it's got to send you a bunch of alerts. Hey, your cat just jumped. Wonderful. I don't need a note on my phone about it. What I would like to know is, is my house safe? But the psychology of the system means I won't pay a subscription unless it's doing something that I can then recognize value from. Once we've got a more networked and orchestrated environment through which we're walking through, I actually expect that what will be over an inflection point, and we'll see more interactions that aren't a screen, which is a hugely unnatural concept. There aren't a lot of 2D representations in nature that we interact with. So I think we'll see more gesture control, more voice, certainly. We're betting big on that on Amazon. But and I think those actually help our brains work more naturally the way that they do.
Yeah, I think the whole screen thing was just a passing phase. I'm very fond of sort of single pixel displays, the little ambient devices, Chris Rose et al., to indicate something with a glanceable display rather than having to deal with all those pixels. I think that whole sort of proliferation, the race to the top or race to the bottom of how many pixels can you get in things is, and as you say, demanding our attention in ways which we were never designed for is quite unnatural, and much more fond of sort of natural sort of interactions along the lines you just said. Yes.
I think it's interesting the way Robert posed the question. I'm going to twist this around a little bit and suggest to you that even if we suffer from the kinds of problems that Sarah outlines, at least in the initial stages of IoT deployment. If we ever get to ecosystem-like behavior, where your house is actually fairly intelligent, and I'll use that word kind of lightly, but it's aware of the various sensing information that it's getting, it can formulate a kind of a model of how the house is doing, whether it's heating, ventilation, security, or other things. The environment will become smarter, even if we're not. And it may be able to manage the environment that we're in more effectively. And in that case, once we believe we can rely on it, that's a very important question, we may relax a bit, just as Mark Weiser predicted. This ubiquitous computing would sort of just blend into the background. We wouldn't think about it. I do have to say that I am a skeptic with regard to voice interaction, even though it works quite well in the case of Google Assistant and Siri and Alexa, for example. I find myself imagining that I'll have this debate about which light bulb I'm trying to turn on. And I have to give them names like George and Frank and Edward. And then I have to train my guests to know what the names of these various devices are so they can flush the toilet. And, you know, somehow this doesn't sound right to me. And precision may be the antithesis of the voice interaction if we want this to generalize for, you know, people who don't live in that particular house or are not in that particular building all the time. So I'm still struggling with the utility of some of these modalities.
I would actually, I think a lot of the voice will be much more useful when we have that, you know, the semantic modeling that we were talking about a little bit earlier, and that kind of functional equivalent. So I don't have to say, you know, turn on light bulb 7 on row 3 in kitchen.
Yeah, right.
I can just say, hey, I can't see, or, you know, the ambient light level is just, you know, matched regardless of whether there's a bright window or, you know, 4 lights. And I think, to me, where we get to the point of intent, which is when gesture becomes useful too, because, you know, gestures can mean lots of culturally different things. I learned the hard way to Catchpoint in Greece once. But, you know, figuring out what the actual intent is and then understanding kind of the ambient background of that, I think is key to being interesting for anything that's outside of a screen, which is why we're on screens today.
I have to ask, Sarah, have you ever been in a room with an automatic light sensor and you've been quietly reading and the lights go out and you have to go like that in order to say, I'm here, you dumbass, you know, turn the lights back on?
My office every day at 5 o'clock switches over from, you know, lights full on to, you know, if she's in the office mode, and I'm always sitting there and it always goes off every 15 seconds.
But wasn't it you guys that invented the whole clap on, clap off thing anyway? You know, go back to gestures, but with sound, maybe. So, Andy, let you kick this one off, and then Sarah, please feel free to jump in. So where do you particularly see machine learning being applied within the next 2 years? I mean, is there anything that you'd like to see become a reality? You know, for example, for me, I'd like to make the planet a greener place, especially for my 2 young boys.
That's a subject that's very dear to my heart as well. But I think one of the applications we're going to see for machine learning in the near future is what we've literally just been talking about, is the ability to build a cognitive model or a context model of the user and the environment they're in. So if you take an example like tell me when my dad gets home. So we've got a whole bunch of things there. Tell me, so there's a mechanism for alerting. There's my dad, who's that, gets home. All those things, if you asked the average speech recognition system today, wouldn't have any idea what you're talking about. But if you've got a sort of a contextual model of worldview that's set up for me to give me that background, that sort of that worldview, and can interact with that. So as sensor inputs come in, and when the front door of my dad's house gets activated and he walks through the door, so the model now knows, so I can say, tell me when that happens. Oh, he's already got home. So that's, I think, is really where we're going to see a huge leap forward in slightly frustrating sort of request response type interaction with these devices, to a more natural conversation where they seem to know you, they know what you're doing, they know what you're intending to do, and they kind of know who Bob and Jim are when you say invite them to a party.
I would love a system that knows which Bob to call. I agree, Andy. I think that some of the early, where we see a lot of customers leaning into machine learning, deep learning, AI systems is really on kind of a feature level for their own products or solutions. So it is, what cool thing can I add that makes sure that my product is very leaning forward? And that actually is a lot of contextual added. I don't think that's the end of where it needs to be. I think that there is a whole nother layer of how do we machine learning and deep learning in order to better design IoT systems. I think that to me is the real killer app when we're talking about using neural networks in order to design the logic across a fulfillment center or across a manufacturing plant, which we can then now dynamically reprogram much faster. I think that is where we see a lot of some of the most impactful use cases for customers. But that context layer, and particularly for interactivity, that's kind of low-hanging fruit and gets you the big check in the box is, yeah, you get it. You're a 21st century company. Ben, do you think different?
Just an additional thought to what Sarah is saying. This notion of building a cognitive model that Andy poses, I resonate very strongly with. The idea that a building, a house, a residence, a manufacturing plant, has a model of itself and has a model of what's normal, has a model of people who are in it, what's functional and what isn't, and conditions, the situation. So an example. Let's suppose that you have a house full of webcams, but the fire alarm has just gone off. At this point, that's a very special circumstance. It could be that you will want the fire department to have access to the webcams in order to see if there's someone unconscious in a particular room. That's not something that you would want them to have access to all the time, or that the general public should have access to. So there's some interesting things that we can do once you have a model of what's normal and what's abnormal and what to be done under those conditions. And when we get to an ecosystem that has that level of modeling, self-modeling capability, I think we'll be quite far into the utility of IoT.
One of my favorite things about IoT and the sort of the intersection of IoT with machine learning and deep learning is some of the really neat problem sets that come up with the reduction of dimensionality. When you start talking about those ecosystems and how do you model those ecosystems, you think of an airport, you've got so many layers, whether, just in baggage tracking or in turning, ramp turnaround time for an airplane. You've got baggage systems, you've got catering, you've got pneumatic pumps, you got to get the people through TSA. All of those systems, with an IoT background have their own process to manage and then also have interdependencies. And there's an exponential explosion of context there that comes out of this. And from a mathematics and from a, if I were in school today, what would I want to, look at? What would my PhD thesis be instead of materials physics? For me, it would be looking at, reduction in dimensionality and how do you marry what we can do today with compute with some of these highly complex, highly interrelated problem sets. To your point of it.
Thank you. So Vint, people these days are apped out, in quotes. So downloading an app per IoT device, stops making sense as IoT device proliferation continues. So what do you think are the most promising solutions to this?
Well, it's pretty clear. I will speak only for myself. I'm very unhappy with the number of apps I have to fuss around to find in order to do something. And the idea there might be an app per device just drives me crazy. So what we need, frankly, is what Andy was hinting at, and that's having a model of the ecosystem in which these devices have been embedded, so that we have sort of a software model that we can interact with in a very straightforward and simple way, not app by app, which I think is an artifact of the smartphone. At some point, I think that's going to not scale at all. In fact, we may have gotten there already. So I would prefer to have simple ways of interacting. And as I say, I'm still a little skeptical about some of the voice interactions. Some of our listeners have already suggested Moti Barkan, for example, says that there isn't any need for complicated interaction with lights. The system will know where you are, what you like, and so on. I actually am not comfortable with that formulation. I want to be in control. I don't want the house to be in control. I don't want it to guess about what I want and don't want. I have some devices that are trying hard to learn what's normal for me, and they always learn the wrong thing. In particular, the device that thinks that I'm never home, because the sensors for heating and cooling are in places I never go, like the formal dining room and the upstairs guest rooms. And so the system thinks we're never home, and it keeps the place hot in the summer and cold in the winter. We're unhappy about that. So I think there's a lot more to be done here to make the system more responsive and more easily managed by the people who use it. One other point, the last thing any of us want is a house that stops working when the internet isn't connected. And so to the extent that we're relying on cloud-based systems to do a lot of the intelligence, we had better have the ability to do something locally, even if the internet's not there. That makes sense. Otherwise, we'll have a lot of unhappy customers.
Yeah, and part of that interoperability thing we talked about right at the beginning currently assumes that you take the data up into the cloud and then you do the interoperability at the top. But as you say, if the link's down or is a high latency link or some other problem, then in fact the ability you actually do the messaging locally to interact with these systems, so that your thermostat knows when the window's open, knows when the heat is on at a local level, is just as important as the semantically rich, data-heavy approach you can get from getting the data out of the cloud.
I would agree with that, although, part of the chat at the moment is about, can't we just use the home router as kind of the point of security, or at least as the point that we as homeowners or we as owners can control and direct from. And I think one of the big challenges with Edge as a local mechanism is that it is dynamically changing for any device that can get up and move. And so there's this flexibility that has to be in the intelligence layers and the security layers to know what group am I controlling it, and because I've got that set of that viewpoint, that shadow of the world, what then do I have the right role to, what decisions can I make, what enforcement can I do, and what do I need to percolate up to the next layer. And we haven't gotten to that point yet, which I think once we do, we can get rid of a lot of the end, direct to user connection points, whether those are apps or even physical buttons.
So Andy, oh, sorry, Vint. You're on mute, Vint, if you can hear me.
Oh.
Still on mute, Vint.
Yep.
I'll
see if I can unmute in this end.
Oh, I'm sorry.
So I unmuted
Sarah
you.
said something really profound here. She implies something about configuration, which is not an episodic thing anymore. When devices can be moved around in and out of the house and so on, you're literally in continuous reconfiguration mode. The system has to be able to adapt to the presence of devices that arrive and leave. That's a very, very different environment than now I'm in configuration mode, now I'm in user mode. I hadn't thought about it in those terms, so thank you for that, Sarah.
That's a really good point, yeah.
It's one of my favorite go-to topics for presentations at the moment is the effect of IoT on products. And if you have, once you connect your products, that's where a lot of industries are today. How do I connect that one device? And for me, at the bare minimum of what we get out of connecting devices is the ability to do, as you said, Vint, that update. Well, once you can update and you can manage that process, you can basically move from kind of what in IT is called a waterfall design method to a continuous delivery, even on hardware. And so the ability to change what is happening on that device, we have serverless compute's a great mixture with IoT, because it gives you that kind of that quick control mechanisms, but I think that the ability to experiment in field, in situ with devices, and to be able to change and to do A/B testing, to figure out what are the right features for you, Vint, or you, Andy, or me. I think that constant change, and that comes down to both the individual device can be changing consistently. What am I measuring, and how am I percolating, analysis from that device, as well as the group of devices is also in constant change. So change is exponential as well as complexity of the ecosystem.
But I think there's a whole paradigm shift needed there, because at the moment, updating your router or whatever normally involves a period of time when the thing's offline. It's quite an overt manual effort, or even if it's automated, it's still updating now, go offline, reboot, etc. But what you're alluding to there implies a continuous change, sort of small increments, which none of the update mechanisms I've seen sort of commercially available in the standards has been anywhere near geared towards that. It's always been download a new firmware image and then kick over to it. So I think I know things like OSGI can dynamically unload and load bundles on the fly. So I know that technology exists, but it's by no means widely used.
Yeah, I think it's just starting to come out. We have something called Greengrass, which is serverless. And there are folks who are doing the same or similar things with containers on the edge. So you can basically hot swap containers. I think there are some really interesting business models that percolate out of those things. Can I rent you space on my home, vacuum cleaner for an app that, goes through and figures out, the square footage of my house, for instance, as part of a survey of usable space to sell my IKEA furniture. I don't know, I'm making this up, but you start thinking about, how those space can be used, not just by the manufacturer, but potentially by others.
So Andy, how is blockchain technology going to play its role with IoT? And is there any indirect or direct relation between both?
That's a great question. So in many ways, we're still looking for the killer application for blockchain, but we're already seeing some key use cases, particularly where IoT is concerned, where it's a very natural fit, that idea of a distributed transaction without it being one single sort of person who's got to be the ultimate person responsible. One of them is in custody transfer between borders. So if you're taking a container on the back of a truck through a number of countries and they're going through secure checking areas, and you want to make sure they haven't been tampered with, and you can't quite trust any individual party, but there has to be that end-to-end trust to get these containers securely through, making sure it's being checked in the right places. So the ability to incrementally chain into a blockchain as those transactions happen through the journey is one that we're seeing a lot of interest, where it just happened. It seems to be quite a natural fit for the IoT devices on the container and the sensors in the secure loading areas, and the fact that's all committing to a blockchain. The other thing we're seeing is where it's worthwhile investing in the technology to track high-value items. So looking at leather jackets in a store, or very high-value items like an aeroplane, say, if someone's selling it and transferring it through a number of middlemen and women to transfer it to an end destination. Whoever takes responsibility for it at a certain time in his journey, again, having that committed to a blockchain which is publicly visible, so you can just see where it is and make sure that it hasn't gone off down some dodgy route. Again, seems to be quite a natural application for it. But I think they're currently few and far between. It's not like there's a zillion applications of blockchain, but I think the ones that we are seeing fundamentally transform the nature of those businesses. I think we're going to see a lot of interest there.
There certainly seems to be a lot of conversation about blockchain. For me, when I first looked at the technology, which granted was quite a ways ago, and Chris Ferris would probably kill me for this, speaking of IBM working on blockchain. But for me, there was an inherent challenge with blockchain in that the amount of compute it takes particularly as your chain grows, in order to get to coherence, that seems like something that is a fundamental piece of blockchain, which makes it, the more useful it is, the more expensive it gets, at least from a compute standpoint. And I understand, sitting where I sit at AWS, we know that compute gets cheaper and cheaper. But that, along with some of the timing issues on how many transactions a second could be done, I do think that there are some killer apps out there for blockchain, and Hyperledger, looking at smart contracts, where really the dollar savings of the business relationship outweigh the cost of the technology. Costs, I think those are some of the really interesting kind of bleeding edge areas where we're more likely to see it. There was a period about a year ago where the next person who said that blockchain was their answer to IoT security, I was going to have to backhand them. That was a while ago, so I think education has filtrated out, which is great.
So I want to emphasize some of the things that Sarah just said, especially with regard to the parameters of blockchain operation. I have become less and less persuaded, certainly with regard to anonymous blockchain, which I don't find in any way persuasive. I want to know who is running those blockchains. So permission blockchain is more attractive from my point of view, but also the scaling question is important. For certain small size applications, blockchain may turn out to be perfectly okay. But in that point, you may also say, well, there are other ways to do this as well. So I'm sort of rejecting the Kool-Aid at the moment, maybe wrongly, but and certainly with regard to Bitcoin, I'm running the other way, because it's too much like a commodity whose value you have no way of really estimating forward into the future. So I'm not too wedded to that. We're seeing some utility in some small applications for blockchain, some of them related to certificate transparency in the DNS SEC system. But apart from that, I'm not seeing a whole lot of enthusiasm outside of the hype that I think we're all detecting.
Thank you. So we're going to come to our last question on this AMA. And Sarah, I'd like to finish off with you, if that's okay. So what are currently the greatest technical challenges, in your opinion, that are slowing the growth of IoT? And what are your recommendations for overcoming them?
So for me, there are two kind of interrelated challenges that are slowing the growth of IoT. One is how to manage the digital rights management around IoT. There's a piece of it that's privacy, but really it is a combination of some of the contextual systems that Vint was talking about, where how do I share across my value chain? How do I share insights that I trust and that I know, my downstream vendor can trust? How do I share those in a way where I retain my IP and I retain the ownership of my data, but where I can make sure that the action I need to have happen after that happens? So as an example, if you're $1 million, building the big chiller systems at the basement of buildings, how do you let the contract field service tech know, the operations of that chiller? Today I think we provide an awful lot of information, which means that there isn't a huge incentive to make those complex ecosystems scale. So what you see is sort of I like a dimensionality. I think of them as one-dimensional systems. You've got a process, and people can pretty much handle that. But when you start talking about multiple layers of processes, things break down pretty quickly. So a lot of today's IoT customers are device manufacturers. In order to really have the impact of IoT, we've got to get more into the ecosystem plays. And that is in part that data exchange layer and the digital rights management around it. It is also in part the semantic and contextual technologies of how do we make sure that we don't have to script how each one of these systems talks to each other, and we don't have to script what lighting means for the industry. We've got to be able to find these flexible the systems, maybe going back to semantic web technologies with a physical layer. I don't know how you make that happen, but being able to fix that also makes all of the analytics a little bit easier for the next generation of machine learning and deep learning applications.
Cool. Thank you very much.
Not quite sure how to follow that. I think if you had a semantic namespace, so you kind of do DNS but at the application level. So rather than having to look up IP addresses, you're saying what's the business endpoint of this thing, and you find it directly. So part of the promise of some services-oriented architecture, I guess, then that would really make things rather interesting, because you'd just be looking for the service you need, and not have to worry about anything else below that.
So it's Vint again. I'd like to emphasize an issue that I failed to take into account sufficiently in the case of internet design. When we started, we were a bunch of geeks and we're just trying to make this thing work. And it didn't occur to me anyway that somebody would want to wreck it. And why would you do that? We're trying to just figure out how to make it work. So we didn't really defend early on against some of the malicious attacks that we now see plaguing the net. There are defenses against that. But in the IoT space, this conversation has caused me to conclude that the ability to sense a new device, to incorporate it into a model of an ecosystem, to detect that this device might be malicious, for example, and defend against that, is really a hairy problem, because things come and go in buildings, especially the public buildings. People walk in with the devices, as Sarah implied. They move around. The idea that you should treat every device with a certain degree of suspicion until you have figured out that it isn't is the inverse of the normal innocent until proven guilty. Right now, we assume guilty until proven innocent. And that may offend some people, but I think that's actually the right paranoid position to take if we want these systems not to be easily invaded by people with malicious intent.
Cool. Really so, Andy, we've got one cheeky little question just popped up that I'm just going to close out with. Shouldn't take you long to answer. So, which platform is better, Arduino or Raspberry Pi?
Well, it does depend what you're doing. I'm a great fan of both, as it happens. I'm a particular fan of ESP8266s at the moment, which is an Arduino with Wi-Fi on board. But I've got lots of things running on Raspberry Pis, and I'm very fond of the Node-RED software, because it just makes it really easy to wire up a new program and get it working really quickly. But if you want to do things, very small, and here's one I made earlier. Here's a little ambient device. Oops. I was going to show you a little ambient device that we've got here in Munich showing CO2 level sensing. You can't beat an instant on Wi-Fi connected device for doing that. So both is the short answer.
Did you see that project recently for the Raspberry Pi that created the weather station, whereby it actually created the mist, the rain, the lightning, the sunshine? I thought that was brilliant. I
was just reading it before this session, in fact, yes. Fantastic.
Oh, right, okay.
And we're going to be building one of those next week here in Munich.
Oh, cool. Excellent. Well, all of you doctors of IoT, I would like to thank you very much for today. I'd also like to thank everybody for joining the discussion today. We've had some amazing questions today, and I'm sorry we couldn't get to them all during this broadcast. We'd also like to thank IoT Central and the IoT community for helping sponsor this particular event. And of course, coming back to Vint, Andy and Sarah for giving up their time and going through all these questions with us today. We really, really do appreciate it. And it's been an absolute honor to sit and chair this panel for IoT. So as I mentioned before, we will be sending out a recording and transcript shortly, as well as other resources from the panelists, so look out for that email. I hope you all enjoyed this AMA. We look forward to seeing you on the next one, and have a great rest of your day. Thank you very much.
So, pass the banana.